It's a very simple talk. It talks about Linux kernel upgrades and general upgrades and tries to actually break all the patterns specifically to the Linux kernel. So thank you for surviving the second day, and yeah, I'll try to make it quick and not stand in the way of the happy hour, right? So my name is Ignat. I do Linux at Cloudflare. I like system security and performance. Also enjoy low-level programming like Linux kernel, drivers, bootloaders, and other stuff, scary stuff written in C and assembly. What would you do in this case? So imagine you're just working, you get this, right? Everyone's seen this. You get updates. Would you install them? Who would click like, yes, right now? No? No one. If you didn't click for your laptop, you would definitely don't click this if this was a production machine, right? Server. So when it comes to upgrades, like the production machines you have two choices, remind me later or completely disable, so never install updates. And this is natural, right? Like we're all SREs and developers and production engineers. So how do we perceive software updates? Well, not that great, right? Something which can break our systems are scary. However, with regular software updates, yes, they're monsters. They're monsters, they're not pleasant, but that's kind of okay, right? They're more like these type of monsters. But when it comes to Linux kernel upgrades, so it's a little bit different, right? So we perceive them as something really, really like trying to break everything in the world. And again, this is natural because when we know how to deal with bad software generally. So if we have some kind of service, it crashes, yeah, so we can deal with that, right? So we can write a systemd file which says restart always and done, we're done. Go home, right? On the other hand, when the Linux kernel crashes, you get something like this, in which my colleague talked about Linux crash dump today. Your whole system is down, your service is down, everything is cascading failure and like the end of the world, right? So we don't like Linux kernel upgrades, and I have seen in many places and talked to many people that people try to avoid them as much as possible. So whatever is kernel upgrade, like they try to push it out, like do something else and find an excuse not to do it. But there are risks, right? Like, why should you apply updates and Linux kernel updates in particular? Well, if you don't apply updates, well, basically the bugs are not getting fixed, right? So you have bugs, and how many bugs? Well, this is the graph I updated today, actually. So by far, if we take the Linux 5.15 branch, which is the latest Linux long-term release branch we're using in production now, and I'll be talking about Linux kernel release procedures somewhere in the future. So they usually make weekly patch releases. And this is the amount of fixes getting into each release weekly, right? I'll be talking about releases a little bit later, but this is the amount only of bug fixes and security vulnerabilities went into each release. So you see the graph, and the statistics are, so far we had 68 releases, like the last release was yesterday, and 36 of them have more than 100 commits. So more than half have more than 100 commits. There are certain releases with more than 200 commits, and 5 releases with more than 600. So imagine not applying a single update, you're missing out potentially at least 100 bug fixes. Secondly, if you don't apply updates, you don't get performance improvements. This is the real snapshot of graph from Cloudflare production systems. This is where we tested 5.4 kernels to 5.10 migration at some point. And this is basically before and after. So this is like the test, control and test group. The control group has the same characteristics, and the test group has much more memory consumption. So this is a graph which shows memory consumption on the node. So we roughly, just by upgrading the kernel, we saved somewhat 4.5 gigabyte of RAM per server. And you know, RAM is expensive these days. And thankfully, this is just to some folks from Facebook who contributed their improvements to memory management subsystem. So you get this for free, right? Second, another thing you're missing is you're accumulating change data. So this is the same data as I show above, like number of commits per release, but it's now accumulating. So it's like this shows how many commits from 0 release, the third shows from 0, 1, and 2 release, and so forth. But this view of data shows you a nice pattern, right? So imagine basically you're now on release 5.15.16, right? And you're thinking about, why don't we upgrade to 5.15.32, right? So you can calculate your change delta. And why is that important? Oftentimes we associate changes with risk, right? So it's natural to say the more changes you are applying, the more risk you have, right? So like we have like 2,196 commits now. And like, but let's say you went to your production team and said, no, this is not a great time to upgrade. Let's do it later, right? So you delay your upgrade by the same amount of time. So and because they're like mostly regular, weekly, when you again decided to upgrade, right? You're upgrading from 5.15.16 to 5.15.48, and now your change delta is 436 commits, which brings a very important point that your change delta, thus your risk, which is proportional to changes, grew by almost 2.5 times, whereas you only delayed by 2x your update, right? So the more your risk grows faster than the time you delay. So the more you delay, the risk might grow faster, breaking your system when you apply that update. Yeah, for a 2x delay, we get 2.5 more risk. Security patching. If you don't apply updates, security vulnerabilities are not getting fixed, right? This is another graph, which is similar, but it only shows you number of CVEs patched per kernel release. And some statistics are, out of 64 releases, because there is no data for the last 4 yet, 48 of them had at least one CVE patched. More than 75% of weekly releases have some kind of CVE patched, at least for this kernel, right? And there were 8 releases with more than 5 CVEs patched. So I don't know how to calculate that out of 64. So it's pretty much high. If you miss one release, you're missing a lot of CVEs. And it's not only bad for security, it's also bad for compliance, because you have a time frame, right? If any of you are managing a system, production system, which is the IDSS compliant, there is like the latest version, it was paragraph 6.2, but now it's paragraph 6.3. It's like, says critical high security patches should be installed within 1 month of release, right? So the moment the patch is available, you have 1 month, and probably like the Linux kernel should be considered a critical component, because we discussed why it's so important. So you have 1 month to get it out to production. Who here doesn't know about Equifax and what happened to them? Yeah. So Equifax didn't patch their systems, and they went in big trouble, and still probably paying to their customers for their negligence. So it leads us not so fun fact, because security patching of the Linux kernel usually requires a reboot. If your server uptime is more than 30 days, you're most likely vulnerable, and not PCI DSS compliant, because most likely, because every release has some kind of CVE, you're probably nested. So these are all risk of not applying the upgrade. I talked about earlier that like because upgrades are so scary, right? Like people in various organizations, people come up with excuses not to do them and doing, and especially including Cloudflare. So this is what I've been fighting for, and changing how we view the Linux kernel upgrades, right? And yeah, I also at many conferences talked to other SREs, and they roughly have the same anti-patterns, which comes from the traditional like software change management, I guess. The first thing they asked when I said like, yeah, we need to upgrade the kernel, like, okay, which things from the change log are actually applicable to us? So why do you want to upgrade, right? And again, we come back to this graph. So like the weekly releases, like I have a weekly kernel release, and most of them contain more than 100 commits, sometimes 600 commits. Do you want us to browse through 100 commits every day? I can't say really, right? So we just approve. If I do that, I'll be only like browsing changes and nothing else. Similarly, when you want to say, oh, there is a CVE there, we want to patch it, and they ask like, can you prove this is really applicable to bus? Is it exploitable on our systems, right? But the problem here, they're asking the question to the wrong person. So let's think about it in a way. So imagine your system, like you're running a system with a CVE, which is unpatched, and you don't really know is it exploitable or not, right? The person who will try to exploit your system is the attacker, right? And who is this attacker? It's a highly motivated person to break into your system to get some value out of it. And what they do, they spend like exclusively 24/7 of their time and resources to do that and find the successful exploit. So most likely, if your system is exploitable, the attacker will find a way to exploit it. This person knows if your system is exploitable eventually. But you're not asking the attacker, you don't know who it is, right? You're asking either my team or some kind of security guy or someone else or another systems engineer like who just briefly looked at the description of CVE. So what are that person? They're highly motivated to go home on time, right? So they will not be doing this. And probably it's not only their main job, it's like they need to, maybe if this is a security person, they may need to review several patches a day, and they have other competing priorities, right? So this is more likely this person who has many, so like their attention span to the detail would be like minutes, and they will say yes, no, but you cannot really trust that opinion in my view. So, and some, especially kernel exploits, are very complicated and hard to assess whether it's applicable to your system or not. And so I've seen also like a very successful attack where an attacker was able to successfully compile 3 or 5 minor vulnerabilities to create a privilege escalation, which is a high one. So like attackers are very creative at that point, but we're not asking an attacker to do that. Some would say, well, yes, like we can do these releases, but let's have this procedure. Let's like soak it in Canary for 1 month to ensure the kernel is stable, right? Before like rolling it out everywhere. But remember this graph. The more we soak, the more we wait. The more we wait, the more we accumulate delta change, and the more we accumulate, the more risk we have, which grows actually faster than we wait. If we wait, we don't patch the CVEs, and we're also risking being a security breach and also risk being breaking the compliance, right? So like 1 month of soak time means you're already breaching the 30 days requirement from PCI DSS because you will not be able to roll it out to production after 1 month. And also, if you think about why do people ask for soak time, people ask because they don't know what they're looking for, right? If you have like proper test coverage, monitoring metrics, you deploy it and you see it within minutes or hours or the next load cycle. So it's most likely lack of metrics of observability. It may also mean we don't know our workload. Like we don't know what user space applications are doing on our kernel, which subsystems they're using. So therefore, if we knew that, we could probably stress those subsystems and ensure these specifically subsystems or kernel features are stable for production use. And probably it's also lack of sufficient pre-production kernel testing. So we need more coverage, we need unit tests, integration tests, and performance tests, and whatnot. Finally, there is this human factor, right? Like the kernel is just too critical. It's like this component. Let's have a process which would have more approvals before we can deploy. Like regular server requires 1 approval, but the kernel let's have 3, right? Like and again, this is natural because this is our perception of a kernel break this month. But what if I told you that kernel deploys are inherently safer than any other software? Would you believe me? as an example, it's a real world example. This is roughly Cloudflare network today. We have like many data centers across the world with many servers, and we've built like a very robust pipeline to deploy software, right? But think of this from what is the regular software package deployment process look like for us and probably for many companies which have proper deployment automation. So yeah, like we upgrade the software package so developers do a new release, commit the package to the package repository, right? But the gist here is that if you have this automation pipeline, new, better, good code can propagate to production in minutes without appropriate safeguards. If you do like a stage deployment or a stage rollout. And actually in Cloudflare, we learned that the hard way. There were a couple of really bad incidents where a bad software deploy almost took the whole network down. It comes from regular software. Now, if you think about how do we roll out the kernel, the biggest thing is to roll out a new kernel, you need a machine reboot. And how reboot looks from our perspective, like in Cloudflare, like we have the reboot process automated, but it's still not fast, right? So we drain traffic from the server, we mark it as put it on production, silence alerts, do the actual reboot. When it boots, servers don't boot fast, unlike your phones. We also, like our config management kicks in, we're waiting for the server to be reconfigured. Then we run some acceptance tests, like to make sure everything is like working as we intended, the networking is up and like services, packages are installed. And then we put it back to production. It's not a fast process. Also, while we built this reboot automation, we were not insane, and many companies are not insane. Right? You won't be rebooting all the servers at once. You will most likely have a reboot automation which reboots servers in batches or even one by one, right? So a kernel deploy, actually, it's inherently, even if you don't have specific safeguards, it's inherently slow-paced, gradual rollout with minimal impact. So you have servers slowly rebooting by one, and basically you have a lot of time to notice that 3 new servers we just rebooted have some kind of problem, and you have a lot of time to stop these reboots and revert and with minimal impact. Are you convinced that kernel is safer to roll out? Yeah, if you're not, read about these 2 incidents. So yeah, partly this like setback of kernel upgrades comes from the fact that I've noticed that many people don't know the kernel release process. So even actually learning the release process gives you more confidence to deploy updates. So kernel versioning looks something like that. Have a number, a dot, a number, a dot, and another number. Like for example, like 5.15.32, which kind of looks like a semver, right? But this is where everyone makes this mistake. This is not semantic versioning. Looks like semantic versioning, but it's not. The way how it works is basically the first 2, which is major, in some semantic versions, this is major and minor. This is just a major version. It's not major or minor. And this is like there is no official name. It's either, you can call it a patch release or a bug fix release. This last number is a bug release, right? And the thing is, when this increments, only this increments, this can never get new features. This can only get bugs and security fixes, and there will never be any major subsystem or code rewrites here. To show how it's worked, this is how the kernel development looks like. So you have this main branch, which is managed by Linus. And the kernel developers, there are like different set of maintainers for various subsystems. And they have their own development branches where actually their subsystems is being developed. And they can be like layers of maintainers. So like there can be a subsystem, a branch for drivers, memory management, net, whatnot. And eventually when like the maintainer decide that like the feature set is complete, they like basically merged their core, like Linus pulls from their branches and merges the code into his branch. Eventually, roughly every, I would say 10 weeks, a new major version of the kernel is released. The release happens by branching out from Linus branch. And then this is where the major numbers are created. So we had like 5.10 kernel, 5.11, 5.12. So yeah, it happens roughly 9 to 10 weeks. And then when the release, and that branch is fixed, in terms of features. And eventually, a security or bug fix release is released, which is released by placing a tag on a specific commit on this branch. So how do bug fixes actually get here, right? So if you find a bug on the kernel, you usually submit it to the subsystem maintainer who owns that system. So for example, we have a bug somewhere in drivers, the fix is submitted to drivers. Eventually it gets propagated to the Linus main branch here, but these so-called stable branches, they cherry pick this bug. So again, this branch never is synchronized with stable branches, only the bug fixes got cherry picked. So eventually when enough bugs accumulate here in the queue, roughly every week a new tag is created on this stable branch. So this is how you only get bug fixes and security patches in these releases. Yeah, and even when the major version of kernel is being developed, the merge window for features are only 2 weeks, and 7 weeks is roughly for bug fixing and making it stable. So there is a lot of testing actually goes into the Linux kernel. Another big problem, a big mistake many people make, on the official kernel.org Lex website, there is a line, you can search for it. It says, leftmost version numbers mean nothing. So 4.19 to 4.20 upgrade may contain more features or breaking changes than 4.20 to 5.0. This leftmost number increments when Linus decides arbitrarily. So this is major upgrade and this is major upgrade, but this upgrade is not scarier than this one, because I've seen people, we're moving from 4.20 to 5.0. There's probably so many changes there. We should really test it. No, you can test it in the same way as you test this. Yeah, and bug fix and patch releases are released once a week. It's a rightmost version number. They usually cherry pick from the main Linus branch, and there are no new features. Therefore, regressions are quite rare. They also contain security patches, and based on the data, I show you so many bugs there and so many security features are being fixed. If you don't want to test major changes too often, Linux kernel provides you some long-term releases. So usually a major release is live as long as the next release is not available. When the next release comes live, the previous release is abandoned. No bug fixes or security patches are back. But long-term stable releases, it's a stable release branch which is released once a year, and bug fixes and security patches are being backported for at least 2 years to that branch. So this gives you more room to actually have a supported kernel for a long-term run. And this is what we use in Cloudflare, by the way. We follow the long-term release branches. Yeah, if you're interested about the kernel release process, here is a link you probably can't see somewhere down. So yeah, how to do safe and easy production kernel upgrades. To sum up what I have said today, don't create a dedicated deploy process for the Linux kernel. This is because kernel upgrades are usually less risky than any other software. A simple stage rollout is usually enough, and kernel upgrades are naturally slow-paced because they require reboot. Avoid just defining bug fix kernel upgrades, right? These fixes, you almost want them, so they should be released with no question asked. And regressions are quite uncommon, and this will allow you to minimize your soak times in canary deployments. Stay on the long-term branch if validating a merger kernel upgrade with features for you is costly, so you might need to do it less often, but you'll probably be missing out on the features, but still it's a reasonable compromise. Definitely don't wait for 2 years. After a year, when the new long-term release is available, start evaluating so you can smoothly move to the new version. And you have 1 year actually to move from one major version to another major version. And you will be accumulating less change delta. And if you're thinking about various soak times, consider implementing and improving pre-production testing for major kernel version validations. You can't do it yourself. You have to work with your engineering teams. You have to understand your workload, what your engineering teams are actually using and requiring from the kernel. Sometimes they care about the performance of disk I/O, sometimes the performance of scheduler, networking, whatnot. and write tests which exercise these various kernel subsystems in the way you would use them, because many tests out there are very generic and probably not specific to a use case. We continuously hit bugs in production for features nobody else is using, and therefore nobody else is testing. So like for most of our bugs, I've been asked like, why no one else in the world reported? Because probably we use it in some special way. Yeah, and make metrics-driven decision, no time-based decision, so minimize sock times in production. There is also this human factor that metrics monitoring and deploy automation can help with human risk perception. Another problem you have to address is that still that perception that Linux upgrade is scary, and before we had like automatic kernel deployment procedure to production, and we had to go through our SRE team, prove the deployment, there was always this like human factor, like especially for newer engineers who just joined the company, oh, should I approve this? This looks so dangerous, and they always try to avoid it. So automation helped us really in this case, that now that our releases are automatic, we actually remove that burden from unconfident engineers to actually do the approval process. And we now do data-driven decision to see if a deploy looks good. Having the automation actually encourages to have regular updates. There's no excuse now not to do it. So yeah, things we talked about today are not more risky than any other software. You need to patch early and patch often. Bug fix kernel releases where the rightmost version change should be applied with no question asked. If you have a procedure which requires you to justify the upgrade, drop it. There's almost something you need there. And basically understanding your workload, metrics, monitoring, automations will allow your system to stay patched and secure. That's it. And thank you for joining SREday and surviving this day. Questions?